First section in Chapter 2 in the elementary statistics course. We'll deal with frequency distributions. We're going to take some things that you've learned in a combination of integrated algebra and the Algebra 2 trigonometry course, and we're going to beef it up. We're going to talk a lot more about it. And mainly, we're going to allow you to create a lot of the things that you're going to do. A lot of what you'll see in the New York State curriculum with the integrated algebra and the Algebra 2 trig is that they create a lot of stuff for you, and they expect you just to spit a lot of information back out. For you, you're going to be able to, in this course, create a lot of the information that the state would have done for you. In other words, we're really starting with a blank canvas. So let's start with characteristics of data. First of all, the center is a representative or average value that indicates where the middle of the data would be located. That's obviously very self-explanatory. Variation, we talk about a measurement of the amount that a data set varies. Typically, we don't want a lot of variation. We'll talk a lot about what that means when it comes to the standard deviation. Distribution is the nature of how the data is spread out over the range of values. Those of you familiar with Algebra 2 trigonometry have dealt with the bell curve. That is the normal curve, normal distribution. We will be dealing with a lot more types of curves in this course. Outliers, I'm sure you've talked about. Those are sample values that lie very far away from the vast majority of other values. If we do the classic M&M experiment, where we give everyone a bag of M&Ms, and most people come up with some range typically between 25 and 29, and somebody comes with some outlandish number like 35, that's an outlier. Somebody might come up with 15, that's an outlier in the other direction. Some people would call that a screw job in terms of the cost of the M&Ms. And the time, of course, changing characteristics of data over time. That typically happens. The mnemonic device for the characteristics of data would be CVDOT. Some people, and again, the stupider the thing to remember, the more likely you're going to remember it. Some people relate this to computer viruses destroy or terminate. CVDOT. Frequency distribution is a table. You've done frequency distributions in the past, but again, a lot of the information is chosen for you, and it just becomes busy work for you. We in this course are going to have a blank canvas when it comes to frequency distribution. The frequency distribution has two classes to it, two columns. Classes and frequency. The class is the range of values that you create. You have to remember that, of course, all classes must be the same size. And frequency clearly is the number of values that fall into a particular class. Let's take a look at example distribution table, and we'll take some more definitions to it. At the left, you'll see a distribution table of pulse rate and frequency. The lower class limits are the low numbers in each of the classes. In this case, it would be 60, 70, 80, 90, 100, 110, and 120. The upper class limits are the high numbers in each class. In this case, 69, 79, 89, 99, 109, 119, and 129. Class boundaries are numbers that are used to separate classes, but you do it without gaps. In other words, if you look at the top class, it's 60 to 69. The second class is 70 to 79. The boundary for the first class would be 69.5. It's halfway between the high number in the previous class and the low number in the next class. Your class boundaries in this case would be 69.5, 79.5, 89.5, 99.5, 109.5, 119.5, and 129.5. The class midpoints are the middle values of a class. That makes a lot of sense. Midpoints are right in the middle. In the case of the first one, you're looking at 64.5. In essence, to make this quicker, add 4.5 to each of the lower class limits. And the class width is the actual range of values in a class. In this case, we're looking at the upper number minus the lower number, so our class width for all of these classes is 9. Your procedure for constructing frequency distributions is to first determine the number of classes. Your number of classes should be anywhere between 5 and 20. And typically we select the number of classes based on the convenience of the distribution. Calculate the class width, and you need to round if necessary. And typically, in this particular case, we always round up. We always want to have more classes than necessary. So if we plug into this formula, which is the max data value minus the min data value, which is the range of the data, divided by the number of classes, that's the class width that we're going to want. We always round up, so if we got a value like 9.2, we'd want to make the width 10. The third thing is to choose the minimum value or a convenient value to use as the first low class limit. The only reason you wouldn't choose the minimum value is if your minimum value was for some reason an outlier. Again, going back to the M&M experiment, if you have one person that had 15, but the rest, typically start at 24 or 25, you really don't want to include that 15. It's an outlier. It's going to hurt your overall frequency distribution. Using the appropriate class width that you found in step 2, you want to create your other classes. At that point, fill in your frequencies. You can use a tally chart if necessary. I always do. I typically use a tally chart. I don't want to lose any part of the data. I'm very careful when I'm counting data towards what I need to do. So here's an example. We have some data here, and what we want to do is we want to construct a frequency distribution. And then at that point, we want to name the lower class limits, the upper class limits, the class boundaries, the class midpoints, and the class width. Here's the responses to our example. First of all, I chose to have 8 classes. It's a nice, easy number to deal with. So I take the high value, which was 96, minus the low value, which was 60. That's 36 divided by 8 gives me 4.5. So I'm going to round that up to 5. So my class width is going to be 5. I'm going to start at 60. And again, I'm going to create my classes by creating first all of my low class limits. That's 60, 65, 70, 75, 80, 85, 90, and 95. I then fill in my high class limits by going the unit before the next low class limit. So before 65 is 64.
so on and so forth all the way through. So in our example here, my low class limits are on the left, and my high class limits are on the right side of the class. Your class limits might be different depending on the number of scores that you chose. The big thing you want to think about here is that you do not want your scores to come out exact, because then you're going to have problems containing all of the data. Using 6 classes looks like it could be easy here, because 96 minus 60 is 36, divided by 6, so you make each of the classes of width 6, but it gets a little bit more difficult because, in fact, at the end you won't be able to include 96. You'll have your last class being 90 to 95, and that puts you in a predicament, because then that makes 96 an outlier, which in this case it should not be. Your class boundaries are 0.5 above all the high class limits. So for the first one there, it's 64.5, and going down it's 69.5, 74.5, 79.5, 84.5, 89.5, 94.5, 9, and we leave the last one alone. We don't need a boundary on the last one because of the fact that that's our high score anyway. The midpoints are right in the middle of each of the classes. They only have a span of 4, so you can really look at it at being right in the middle. For example, the first one would be 62, second one 67, third one 72, fourth one 77, fifth one 82, sixth 87, seventh 92, and eighth 97. Your homework to start this section out is going to be textbook pages 52 to 53, numbers 1, 4, 5, and 8. Excuse me, 1, 4, and then 5 through 8.